the assignment going? Are you guys feeling like you're understanding how to get those sorting algorithms going, figured out? Anyone finding like good resources online for any of those? Or if we want to go over any of those as well, we can do that today.
Also, don't be afraid to speak up in Zoom. This is like your chance for help.
To be honest, I didn't actually have any questions. I was just hoping to eavesdrop and see if I could learn something new.
Artem, do you have any tips beyond adding print statements to troubleshoot code? You know, like whenever you're looking at flow data, the way data is flowing, just to troubleshoot your what's going on under the hood.
Yeah, that's a really good question. So what is the approach that you generally take, Thomas, or anyone here, when you see a bug or you don't understand maybe what is going on?
I typically plaster console logs or print statements everywhere until I figure it out. But you know, I was just wondering whether you had any other tips for that sort of thing.
Yeah, so definitely a good step is to plaster console logs in. Another good step is to, there's quite a few tools that we could use to maybe make our debugging more interactive. And we can go over a couple of debugging tools if we want. Basically, the whole point is when we write code and something isn't working, we probably didn't mean to write a bug. We probably wrote the code with full intention of it working. I mean, unless we are just troubleshooting, in that case, console logs is generally a way to go about it. I mean, in that case, sometimes when I'm solving a problem and I'm not sure what the output will be, I usually just print the output of some functions. I still go with prints quite often. But there are more interactive and more helpful tools. So when you guys went through your web course, did you guys interact with like a Chrome, the Chrome inspector, or maybe a Firefox or Safari or anything like that?
Oh yeah.
Right. So one powerful use of that Chrome debugger is we can take a look at the source code and put breakpoints in, right? And we could sort of freeze code at a certain point of execution. Is that something that Thomas or others of you guys are familiar with?
And the browser, yes, but on the back end in Visual Studio, what would you really be using there?
Yeah, that's a good question. We're going to do the exact same. So in Visual Studio, actually, you know what? Here, I'm gonna share my screen, and we're gonna go over. Well, let's take a look at the sort algorithm we wrote last time. Full disclosure, generally, I don't actually use Visual Studio for my development. So we're both gonna learn how to use the Visual Studio debugging tools together right now. Usually I use one of, so at work and generally my professional and personal, I use IntelliJ. So IntelliJ or JetBrains, I guess. So JetBrains is a company that has created a lot of really powerful IDEs, so integrated development environments. They're also, so they're really good, but you have to pay for them. You have to pay for them like $100 a year or something like that. And you don't really get all languages supported in one IDE. So for example, I use WebStorm for JavaScript development. I use PyCharm for Python development, and I use RubyMine for my Ruby development. And I like these because to me, they seem the most kind of fleshed out of all of the IDEs that I've worked with. They became famous for writing a really, really good Java IDE. And they also have a pretty good C++ IDE as well. And those environments and those languages, you absolutely want to roll with some kind of development kind of environment. But Visual Studio kind of came out like a couple of years ago. Microsoft surprised everyone by actually creating something people want. And it's free, which is great, and it supports all languages, and it pretty much will do almost anything that you would want. And I sort of just assumed that I could actually probably put a breakpoint right here, and it turns out I can, I think. So like, let's take a look at this insertion sort. I just like tapped right here and put a red dot over here, which I think is most likely going to be a breakpoint. So now if I run the code, when I run it and I right click and run Python file, let's see what happens. Run Python file in terminal. Will it hit that breakpoint? It will not hit that breakpoint. That's disappointing. So that probably means that we want to run this code not in terminal, but we want to run it somehow. Current test file. See, I haven't configured, I think, a runtime here. So in general, your IDEs, pretty much as a rule of thumb, will be able to execute your code. And you should be able to put in breakpoints into the code, and essentially you would have a very similar experience as you would have with the inspector in Google Chrome or other browsers. In fact, these probably existed way before modern browsers incorporated these tools. There is more of like an old school way of also adding in debug statements. And in Python, there is a module called PDB. You import PDB. Usually, you wouldn't import it the same way you would import at the top of a module, because this is meant to be temporary. It's meant to be kind of like a console log. And usually on the same line, you would do something like pdb.trace. And basically what this will do, let's see. Let me just go to the right directory so our code doesn't break, because it can't find. Okay. So PDB. Okay, let's double check. I haven't used this in a while. Essentially, it's the Python debugger. And there is a way to, set trace is what it's called. That's the function. So pdb.setTrace. And what's going to happen when I execute this is now my code, if you could see at the bottom over here, it's now interactive, and I can actually type things in. This is like one of the least intuitive tools to use, and actually has its roots in C++ and C debugging. There is a thing called GDB in C++, which is a pretty powerful tool, and it allows us to essentially interactively debug C++ programs. Now, Python and the tooling around it is a little bit more sophisticated, but we still have this Python debugger module that we can import. And what setTrace does is it says, once you hit this line, put a breakpoint here. So if I type in L is the command to list kind of the current, basically list a chunk of the code out. If you type it in again, it seems to remember where you were, and it'll list the rest of the code out at. I could do something like, I think P is print. And so let's say I want to know what is my value of I at the moment. I can do PI, and it'll tell me. So at the moment, I is equal to 1. If I do P current book, it'll give me the current object. So that's not surprising, but it can do something like genre, and it'll tell me. So this is a little bit more interactive. It's still not as neat as something visual like your Chrome debugger, so we can definitely do better, but this is a good starting point for when you really just want to figure out what is going on at, say, line 12 of execution. So let's say we have a bug where we're not sure why this while loop might be ending earlier than necessary. We could do something like import PDB here inside the loop. And let's quit this right now and try this one more time. C, it will let us continue. So now we're at this next, wait, let's see, N will let us continue to the next line. So now we're at the while loop. So we can press N again. We can press, we can look where we are. We can see, okay, what is J? J is 2. So we can say, and then PI is 2. That makes sense because we've set J to I. Either way, we basically have the ability to interact with the current execution, read what all the variables are. I think C will continue from the breakpoint, and maybe it'll hit it again. Yeah, I think that happens. So J should be 3 now, or J should be 1 now. Nope, it's still 2. N. I'll have to remember all the documentation. I'm sure there's a lot of debugger commands. Yeah. So up, move the current frame 1 up. Interesting. Break, clear. Yeah, there's all kinds of different commands that we could use. I probably wouldn't recommend this method of debugging for the most part. The only time that I would imagine you would want to start using this method of debugging is when you don't have an IDE. I would recommend using an IDE almost any time because we've created tools that are way nicer than this. Situations you might find yourself not having an IDE, let's say you're interacting with some code on a remote server, and the only way to access that is you have to SSH into it, and you're just in a command line, and you're looking at some code. You might want to quickly modify it and maybe run through it or something. In most of my professional career, that's almost never happens. So this was mostly reserved for me debugging things while I was in school. So I would say that, yeah.
Yeah, I was actually playing with the little red dots there, and if you right click on one, it'll give you several different options of what it'll be. I actually never noticed that because I've always been on the right hand side of the number, but whenever I went over there and seen the dots, now that you pointed out, that does work.
Yeah. I'm just I don't know if anyone's already if anyone already knows. Oh yeah, by the way, the GitHub feedback.
If you click the that little icon on the left, like it's a bug with a cross or.
Oh, okay. This.
Yeah, you can. Yeah, that opens the VS Code debugger.
Oh, so. How do I?
Yeah. Then you just click Python file, and I think you should be good.
Oh, that's wicked. Okay. So this should probably, oh, wow, look at this. That makes sense. Okay. I have a bit of a weird file going on. I'm sure that wherever Python is executing at the moment, it's executing probably from a weird file path where it doesn't know where this books data is. Maybe we should look at a, let's make this a little easier for ourselves and let's get rid of any of this code. This code's a little weird, or a little bit more difficult to deal with. In fact, let's actually just quickly modify insertion sort so it just deals with numbers, so that we don't have to worry about the class that we've created. This will make these examples a little bit easier. Whoops, current num.
Artem, do you know about Control D?
Yeah, I just figured
Okay.
this wouldn't be so slow, but it's a little slower than I expected. Is Control D like how you would, whoops, you know, okay, you know what, also, I grew up learning how to program using Vim, and I cannot use a computer, or I can't use an IDE without it, and so my Control D is mapped to something weird. So my Control D is mapped to go down, and Control up is to go up. So I have basically made it difficult for myself to use any computer ever, except one that I've configured for myself. Would I recommend that? Absolutely. Absolutely, I would recommend. Everyone should be using Vim for their, it's a lifestyle.
I saw someone tweet today asking, like, saying, how much would I pay to unlearn Vim just so that I type normally?
It's kind of funny because anytime at work, if we do some pair programming, so anyone comes over to my desk and we try to debug or come up with a solution together, anytime someone sits down and starts typing on my keyboard, everything just like chunks of code just get deleted, like files close, windows open. It's like with 2 keystrokes. Yeah, I actually, when I first started like professionally programming, my manager at the time was a really heavy Vim user, and he actually never left the terminal ever. And so maybe a part of me just wanted to impress him. Maybe a part of me just wanted to like learn from someone who's clearly very advanced in their usage of Vim. They looked like they really had their workflow figured out. So I just started. This person was so advanced that they like contributed to the Vim project and actually created many different plugins and things like that. Little did I know they were going to ruin my life. Either way, so now I just pretty much take any new editor and set Vim mode. And so when I have to do like the most basic modern things like rename the definition of a variable, I have no clue what the proper command is. There's like a Vim command that I have also forgotten. It's like I'm in the worst of both worlds, where I'm not even that good with Vim and I don't know my IDEs. With WebStorm, I've configured it enough to really like work with my workflow. But Visual Studio, I use it to teach you guys because most people, I assume, would have access to Visual Studio. But here we are again, learning it all together. So if I press play, okay, there must be a way to also, let's see, what is add configuration? Debug currently active Python file. Okay. All right, this is because there's no code. That's right. Let's hide this. So right, we want to sort in some array. And then we want to print, let's print insertion sort of L. Cool. So if we press this debug, great. We're now in In the actual execution, we're on line 11. And over here, it's pretty nice. We can see all the variables already defined, all the local variables. Imagining if we hover over each of them, we can actually see what their values are, which is pretty sweet. Wow, yeah, this is pretty cool. So, Thomas, to answer your question, instead of sometimes, like to be honest, I would definitely start with console logs quite often, because what we're trying to do is we're trying to answer the question, why is my code not working? As far as I can tell, I wrote the correct code for what is in my head, right? And I imagine that all of the variables are in the right place. But clearly they are not, because our output isn't what we expected. So we need to gain information. We're trying to figure out, okay, what are these variables actually set to? Maybe we forgot to set some variable, maybe we forgot to update something. So if we, for example, removed this minus minus, and we just went and ran through this whole thing, our output would not, our output would not be what we expected. Is this gonna work? Oh yeah, it's hanging up, and so we're not even sure. So we probably want to throw in some kind of breakpoint. Are we at this line now? Yes. So we're trying to think, okay, at this point, j is equal to 1, current num is 4, so we're looking at the second integer. It's less than 7, okay, great. So we want to execute the code that is inside the loop. We are doing that, which is great. So now array of j is going to be both 7 and 7. That's good. We're going to kind of overwrite it. And then let's go to the next line. J is now still 1. Current num is still 4. And so on and so forth. And we can kind of see, okay, wait, at this point, does that make sense? I mean, now we're just repeating the same thing. So obviously we're forgetting an actual condition where we want to move the while loop along, move the index that we're looking at in the array along. So I mean, that one's a bit of a simple debug, because it's pretty clear that infinite loop indicates that something's wrong, and we can see that in an infinite loop, probably what's happening is we're never reaching this condition for some reason. This one's simpler than usual, but it's hard to come up with examples of things to debug when there aren't any real bugs in the program. But I would probably recommend getting acquainted with your environment and really understanding what Visual Studio or whatever environment you have has to offer. Knowing that every environment has a debugger is pretty important, because for sure modern environments will all be able to allow you to just basically click on the line of code that you want to breakpoint at, the same way the Chrome debugger does, and then inspect each line. It's a pretty powerful piece of knowledge, because then you could go ahead and Google with that knowledge and see, okay, how do I get the output of all of these variables, or how do I make sure that, you know, I don't know, maybe there's some other kind of tools at your disposal that at that point you just pretty much go ahead and Google, but definitely take advantage of of your environment. And in fact, I've been through several interviews as well, where interviewers would encourage me to bring in my own computer so that they can see my workflow as well. Sometimes sometimes you might find like a Visual Studio or some other workflow already set up for you, and part of what an interviewer might be looking at is, do you know how to use the tools at your disposal, and are you using them to the full potential? But also, like 99% of my knowledge of different different tools and whatnot usually come from watching other people and their workflows, and just generally being curious and stopping them and asking them, hey, how did you figure out where to find the definition of this variable, for example? How did you do that? You know, in here we can go to definition, and it'll pop us at this line, for example, which is kind of cool. Cool. Yeah, Thomas, I don't know if that feels like it was a way longer explanation than potentially necessary, but hopefully that gives you some new insights.
Yeah, I guess the biggest one there is that little dot there, because I am printing my statements now, but to be able to go on the loop line and be able to see what's passing through, and to add that expression in the red to stop it at that point so you can see what's running through is going to be helpful.
Yeah, definitely. That being said, I'm not gonna lie, I still throw in print statements all the time.
Oh yeah. Mine's loaded with it, but
Yeah.
I was just looking for shortcuts.
Definitely. Print statements is the shortcut. Also, yeah, Michaela, using Vim terminal to impress people at coffee shops. I look like a elite hacker all the time, just like getting my Vim on in my iTerm. I used to have like such a complicated Vim configuration that it just was, I didn't even realize that it was slow. I used to have like autocomplete in it, and it was able to find definitions of functions. And then I saw a coworker use WebStorm. Yeah, hacker typer. That's what it really is all about. But yeah, I didn't even realize just how much slower my Vim was literally running because it was so loaded with plugins. So always nice to once in a while step back and reevaluate your tools. Definitely a mark of a good engineer whenever you step back and ask yourself, do you have more to learn?
So I would just Google this, but I actually block Google on my browser so I don't get distracted during class. What is Vim?
You blocked Google of
Yes.
all things?
Well, because I could Google things forever. Forever.
That's so. I mean, I heard people blocking YouTube or Facebook, but Google, there's.
Yeah, I occasionally am like, oh God, I really need to search a thing, and so then I sin and I go to DuckDuckGo. But
Fair enough. So Vim, so Vim is short for VI improved, but VI is basically a text/code editor. Is a screen-oriented text editor originally created for the Unix operating system. So back in the day when we pretty much all lived in the terminal, and to this day, I certainly still use a lot of terminal functions, or like iTerm in my case. Vim is just a way for me to, it's basically like a text editor. It's like an IDE inside of the text editor. So here's Vim. And there is a lot of different commands. So when I first would open up Vim, I would like type in EX, and that would give me the Explorer for files. So here we were looking at sorting algorithms, part 1. And we were looking at this file, or no, we weren't looking at this file. We were looking at Vim, where was it? It was sorting source. Part 1, we were looking at sort 2, for example. So my Vim is probably a little bit more configured than most Vims. I have syntax highlighting for Python, it seems. I could basically traverse and edit my file right here. And that's literally what it is. Like I'm now traversing using only my keyboard. I can't actually, I can click around, but that's only because iTerm allows me. Technically, you're not allowed to click around. And so you have these basically keyboard only ways of maneuvering through code. And for some people, they find it to be a lot faster and maybe more efficient. Usually your hands pretty much always stay on like the home row at this point. I'm navigating using J and K and H and L, and not using arrow keys, for example, so that your hands have no moving. So that's Vim. When I say that I am used to this, it means that my Visual Studio is configured to also use all of the like key bindings that Vim is in. So like right now, my cursor is fat because I'm not in insert mode. And as soon as I enter insert mode, I can start typing things. But up until then, me pressing K and J will go up and down, for example. So I'm not actually using the mouse to traverse. And that's why when Michaela suggested that I use Control D to most likely replace one variable name and all of its instances, I can't do that because my Control D makes me move one kind of like 20 lines down, and Control U will go up a certain page number. I don't know.
Okay, yeah, because I hear a lot about Vim being faster and key bindings and things like that, but I just didn't know what it actually is.
Yeah. I think that the idea with Vim and why it might become, it's definitely slower when you first start. It's horrible when you first start. It makes no sense. I actually went on this little game, Vim game or something. I can't remember the name of it. Vim Adventures potentially. Yeah, I think I went on this for a while to learn how to. Oh, it's got a lot of music. Basically, I went on this game to learn how to move around, because I was not used to using H, J, K, and L. So in this case, like K is up, and now I'm a lot better at it. But at the time, it was very difficult to play something like this. Even I don't know. Basically, it's definitely slow, and then there's a peak where you sort of start to really improve on your productivity. But that being said, I think with modern IDEs, you still have to learn how to navigate your code base. You still have to learn different key bindings, and those things will make you a much more efficient programmer. If you like find yourself all the time, let's say you're always replacing, like you want to change the name of this variable. I bet I can probably turn off my Vim. I don't even know how to do that in this. But let's say you're like redoing certain steps over and over. It's always a good time to ask, is there a faster way? And almost always your IDE has thought of it before you have, probably, because many people run into very common patterns of repeated work. And I mean, like, for example, I use this feature all the time when I'm in a file and I don't know what a function does, and I don't even know where it is because my code base might be hundreds of files big. I would right click and I would press go to definition, and it would find in the IDE where that function is defined. That's so useful because otherwise I would have to either know or guess or I don't know, ask somebody, and all of those things are so slow and inefficient. And so knowing that your IDE actually keeps track of where functions are imported from, I can even peek at it and take a look a little bit to just like, okay, that's what it is. Cool.
Are you able to control click?
Let's see. Control click.
In case he's not, what does
Or
that do?
command, I suppose you're on an Apple.
Oh yeah, totally. I could command click. Yeah. But I never touch my mouse, so I don't know. I could press F12. That's what I would do probably. I try not to touch my mouse. Yeah. The problem was I actually had two managers in a row, two different places I worked at that were both heavy Vim users, and that just like spun me out of control and put me into this dark path. Yeah. Cool. Also, yeah, Kevin, you can definitely lord your Vim knowledge over people quite effectively, and think highly of yourself if you're a Vim user. Some people take it a little too far and think that they're maybe they know something that others don't because they're Vim users. I like to keep an open mind, make sure, because we're always trying to improve our toolkits and what we have at our disposal. So I'm almost inclined to say that for the most part, newer things will probably try to be better, but I won't let go of my Vim. It really helps when you actually find yourself in a situation where you're in terminal. Like, for example, you're you have like some code deployed somewhere on a server, and you SSH in, and all of a sudden you need to like take a look at what code is on there. It helps a lot to kind of have at least a decent understanding of Vim to be able to be effective in those situations. So we're still, since we still live in a world where we have to look at terminal code, it helps to kind of have at least some familiarity. The running joke of like no one ever knows how to quit Vim because it's not like a common command D or control D or whatever, and that's how people, it is :Q, yeah, but basically the common joke is that why did I learn Vim? Because I never learned how to quit it. I never learned how to exit, so I was just forced to stay in it.
So I was I've been trying to make sense of this count sort. That's one of the stretch, and looking at the definition that they gave in at least the setup for the function, it's taking in an array and a maximum number. I'm assuming that maximum number is the maximum value in the array. I just wanted to double check.
Yeah,
my understanding.
Yeah, no, that I think you got it exactly. If I were to, we could definitely go over count sort. That's kind of a cool one. I like count sort. It's got some drawbacks which we could go over, but it's also kind of a little bit more efficient than the other ones. But I mean, obviously, it really kind of only works for the most part for things like numbers, unfortunately, because how do you count arbitrary words or something like that? But basically, yeah, like let's say we have an array like 7, 10, 0, 1, 5, 2, right? For count sort, you said it correct, right? So you say the, how did you describe it again? The maximum?
The maximum value that's in the array.
Yeah, so the count array, that is, right?
Mm-hmm.
Yeah, what would the count array in this case look like?
It would look like, it would be, would it technically be 11, a length of 11, right? Because, yeah, because they said make an array of the max length plus 1. And
yeah.
From what I understood, you'd start by filling it with zeros.
Yeah.
And then you would go through and take the first item, that's 7, and then target the count array at that index, and then add a 1 in that spot. So you're basically counting how many 7s are in there, and then you just go through, count how many 10s, how many 0s, how many 1s, how many 5s, and how many 2s.
Mm-hmm. Right. So we see every time we go through 7, that's the worst arrow in the world. Every time we go, so we started basically going, this is the actual array we want to sort, right?
Mm-hmm.
So yeah, so it's kind of almost, it feels almost like a, like what genius came up with this one? Because we're basically not even sorting the array. We're almost like recreating a new array. We're just trying to gain some information about the old array to basically construct the new array with the same info in it, but in order, right? So we see a 7, and like you said, right, we increment this with 1, right? And that would be like, how fast of an operation would that be when we see a 7 and add 1?
That's a constant.
Array. Yeah, so that would be a constant. And then how many times do we have to run through, or what's the time complexity of running through the whole array?
Just n.
Yeah. So we're going to definitely go through the whole array, and we're going to end up with some kind of count r. So in this case, we would have a 1 here, a 1 over here, a 1 over here, a 1 let's give like a repeating one. And 5 would have 2.
Mm-hmm.
Yeah. So what do we do with count array once we've reached this step?
Then you have to do a running tally where you go through and you add up whatever's in that position plus what was in the previous position. So yeah, it ends up being like a running tally. So it'd be one. The first one would stay 1, and then once we get to the second position in the array, you'd add that 1 to the previous one, and that becomes 2. And then once you get to 2, you add that 1 to the one before, which was then a 2, and then it's 3, and you just keep doing that down the line.
Well, you're describing. Sorry, describe that running tally one more time.
So basically, we're going to take the current index.
Which would we start at what?
I guess we would start at 1. We would start at index 1.
At 1. Okay.
Yeah, and so you would add the value in there. So you take that 1 that's in position 1, and then you would add onto it
of what
of
array?
count array. Sorry.
Right. So we look at this one right here.
Mm-hmm. And then you add to it the whatever's in the position before it. So whatever in position 0. And so the new value at position 1 becomes 2. And so then you do that for position 2, you do 1 plus the 2 that's now in position 1, and that becomes 3.
This becomes 3. Okay. Yeah. And what will 5 become?
5 will be 5. But all the other zeros will be 3s as well. So it just kind of keeps
this
that.
Would be 3, this would be 3, this would be 5, then this would be 5, 7 would be 6.
6, yeah, because that's a 1. There we go.
And then 1, and this one would be 6, 6, and then 7. So basically what we have here is we have basically figured out with the running tally that at position 1, value should be 0. At position 2, we have 1. At position 3, we have 2, and basically go forward like that.
Mm-hmm.
Kind of wonder if we can do it this way as well. If we don't do this tally, maybe that is the right way to do it, but I was wondering if we could do it something like this. So we have what? We have 2 here. So we kind of have like these buckets of numbers. What if we just went through count array this way, and we see that we're at I equals 0, and we see that there is 1 value of them. What if we had like a new array? And every time we just append, we append that many numbers of the index into the new array.
Okay.
So at this point, let's say we're going through the array I equals 0, the value at I, so count. So I think this might work as well. Maybe it's not how it was described. Count array at I equals 1. So that means this many times run append I. So append 0 1 times.
Mm-hmm.
Then we go, now that we've run out of, we've done this as many times as we need, we look at 1, I equals 1, so append 1 1 time. 2, append 2 1 time. 3, don't do anything. 4, don't do anything. 5, append 5 twice. 7, append that once, and 10, append that once. So we will end up with a new array. I guess it's kind of the same. It's basically the same idea. I was just looking at it that way. So we'll append 0 once, we'll append 1 once, we'll append 2 once. We won't append 3 or 4 at all. We'll append 5 twice. We'll append 7 once, and we'll append 10 once.
Oh, okay.
Yeah, so this we will basically loop, like this is at each I. Wow.
Okay.
Yeah, at each eye. So I think it's gonna essentially be the same thing. I should probably read what it said in your description.
The pseudocode one that I saw basically said tally up the counts, and then that the number that's in there will basically correspond to the array position that the number should be in.
Right. I'm just not sure how you would handle duplicates in that case.
It's something about, and then I'd have to go back over it, but yeah, they had a case where you would change because basically it's all about doing a -1 to it to find the actual position. But if it was another one, I'd have to look exactly how to do it.
The -1 makes sense since we're starting, like all of these values will start at least 1.
Mm-hmm.
But I think technically this would work as well. But what kind of scenario, like clearly, what is the runtime of count sort? We can also just go over that real quick in total.
It's linear.
Yeah, it would be a linear sort, which is pretty sweet. But it also has a space complexity cost as well.
Right.
Modify the array itself. This one has to create a new array. So what's the what's the space complexity?
I want to say it was O of n as well.
So this is time.
Every time you add to an array, you have to make a new array, though, right?
Well, no. Well, no, not every time. I mean, an array doesn't regrow every single time. An array will regrow if we run out of space for what it started at. So when you're talking about when we run this append, for example.
Mm-hmm.
Yeah, no, we don't have to create a new array all the time. Essentially, append. We can actually go over this because I kind of didn't go over this in class, but we also will go over this in the arrays module. But basically, every time a new array is created, it implicitly gets created at a certain size that we assume is probably good for a starting size. So append won't really have to go and basically there was already space allocated for I, or for whatever value we're appending to. The array just has a indicator at how big it is and also what's the next index in the array. So it's still an O of 1 operation to append. There is a cost, you are correct. There is a cost where if we do run out of space for the array and we want to keep appending, at that point what we do is we double the array and create a new one. So we create a new array with double the size, and then every time we append to it, it's still an O of 1 operation.
Okay.
So,
but the space complexity, because again, this count array is going to be dependent on the length of the original array. So wouldn't that take up a space of n?
Well, let's take a look. Our old array had 1, 2, 3, 4, 5, 6, 7. So n is 7.
Oh, because it's dependent on the maximum value.
Yeah, it's dependent on the max value in the array. So that's that could be pretty bad, because all of a sudden, if we want to sort something like this, 1 and right, all of a sudden this is like the worst thing we could possibly use. And not only that, but we actually have to potentially iterate through count array in either my description or your description. We still have to iterate. So even time isn't O of n. Time is actually O of max value as well. So
that's right.
We can think of it as linear, but we have to remember that in a practical sense, it's linear, sure, in the sense that the input is linearly dependent on whatever the biggest number is. But at this point, this is going to be so much worse than probably even 2 to the 2. Right? This is like 4, and then this is like 100 billion.
Yeah.
So in the end, the big O notation isn't the only thing that matters. We still have to remember, well, how many milliseconds is this actually going to take? What is the relationship, what is the value inside the O. So there are definitely drawbacks for count sort, but there's also some benefits when you know for sure that it's what you want. This, I think, maybe what I described is called bucket sort, and maybe that's why I'm confused. I wonder if bucket sort and count sort are the same thing.
Couldn't tell you.
You know what? I might have explained bucket sort, and so might have totally went over the wrong thing. Let's take a look at count sort. Just a second. My laptop wasn't plugged in. I apologize. Right. So I think we both agreed on the first point. So take a count array to store the count of each unique object. So here we have an array of size 9. Not sure why they went size 9, but whatever. We technically could have stopped at 8, but decided for simplicity just go for size 9. They counted, there are 2 1s, there are 2 2s, there is 1 4, 1 5, and 1 7. So now what we want to do is modify the count array such that each element of each index stores the sum of previous counts. So, okay, I see. So this is the part that you described. Yeah. Output each object from the input sequence followed by decreasing its count by 1. Oh, okay, I see. So okay. So this is actually a little bit better than my algorithm, now that I realize. Okay, so you go back through the old code and you look at 1 and you check in count how many instances there are there. Right, put data 1 at index 2 and decrease the count by 1.
Right.
Right. Okay. Yeah, so this is actually a little bit better than the one I described because we don't actually, we still actually, okay, no, it's not much better. We still have to go through the entire sum array. So the issue that I described where if we had, you know, a number of 100,000 million, whatever, we'd still have to go through an array of that large to at least make sure we counted up everything correctly. But then at that point, we wouldn't actually have to do that again. We could just go through this. So yeah, it's pretty similar to a sort called bucket sort, which I always thought was a cute solution to make an O of n sort, because spoiler alert for tomorrow, we actually cannot do realistically better than n log n for sorts in as a general sorting algorithm. So sometimes it's kind of cool when we can come up with some kind of hacky way to sort things for very specific cases. Cool. Any more questions? I'm sorry, Lee, I did see your comment on tackling more algo problems on Code Wars. We can definitely do more of those because that was pretty fun. I'll go find some interesting problems. I got a little hooked on it after the previous lecture and started trying out some problems. Problem is, no matter how good of a dev anyone might be, the ones that are like level 9 or whatever they are will just generally take 40 minutes or more to solve, no matter what, because they just literally require so much work. I took a look at some of the 1KY used. Those are, I took a look at them because I wanted to see what they're all about. And some of them are insane. Like, how do I find them? Where's their search? Yeah, let's see. Oh yeah, this one. Oh my God, I looked at this one. This one's crazy. I mean, it takes, first of all, it's this kata, which already takes like 10 minutes to read and try to understand the problem. Probably more than that, but it's a pretty classic programming problem, or even I think this problem might even be like a classic problem-solving problem, where uh, you only have a certain amount of attempts to figure out at what point will an egg drop if dropped from some story. It actually ends up, I think, being a binary search, basically.
Before you say anything else, that's one of the sprint challenges.
Oh, good God.
Yeah.
Okay, well, everyone here might potentially have a slight advantage.
My
We're
God.
moving on.
Time to quit
Moving
now.
on. Michaela, if you didn't say that, I bet no one would have. I shouldn't have kept going because I also don't know how to solve it. But now that you said that, don't go and try to solve this one on your own, guys. Don't think about it. That's pretty funny though.
It's actually it's not that scary. I know that now.
No, you're right. You're right. Yeah,
completely freaked people out about it.
that's okay. I'm sure everyone here. This is like the extra. Everyone here is going to crush it. Anyone who didn't show up, they might have troubles, but everyone here is going to do great. Yeah, maybe it's too dangerous for us to do random katas because I don't know if they're going to show up as challenges. I'll have to vet some of these beforehand. A lot of these are pretty common programming challenges too, though. In general, that you might find in the workplace. So it's pretty good to check them out, no matter what. Yeah. I don't think we'd have to do the 1KYU version of that, the linear version. Not sure about that. Oh, skyscrapers. This is also a classic one. This we might talk about certain solutions to this in the algorithms portion of our course. Oh yeah, okay. Sorry, yeah, we started a little late, but I realize you guys have somewhere to be. Cool, thank you guys for joining me in Instructor Hour and talking about entertaining things. So I will See you guys tomorrow for part 2 of our lecture on sorting algorithms.